So Akash will start your snap for operating system, right?
Yes.
So can you explain me what paging is?
Paging is actually when a process we want to store in a main memory, mm, then we in a main memory with the smallest possible size is page which we want to store, and it is stored in a main memory in a scattered way, and that's the process what is paging is called.
Okay. What's the issue with paging that we move on towards multi-level paging? What's the drawback of paging?
When page table entry in the page table size, it is the page table entry and the number of pages in hierarchical page table. I say the page table size is greater than the frame size, then we cannot store it is in a one frame size. So then we need to divide into multiple paging, multiple level of paging. So that's the need of multi-level paging.
Okay. Okay, can you explain me what thrashing is?
Hashing is generally concept came from the virtual memory. When the many the pages which all the pages we cannot store in the main memory as the process size is big. So few memory are stored in the present in the physical hard disk or secondary memory. So when we want to fetch it, then it is called the demand paging, and that when the for every frame reference we have to counter a page fault, then it is called the thrashing.
So you are saying that when page fault occurs, it is thrashing.
No, when the page fault occurs for every frame reference, then it is thrashing.
Okay. Can you explain me what is Baladi's anomaly?
Baladi's anomaly is generally seen in the algorithm, page replacement algorithm, which generally not follow the stack property, generally FIFO. When we increase the frame size, generally the page fault should reduce. But in the FIFO, we can't see that. Instead of it is increasing. So that's the Baladi's anomaly.
Okay. Can you explain me what is convoy effect?
Convoy effect is suppose at the arrival time there is many process, and it is generally seen in two type of process. It is FCFS and SGF. When the process burst time is huge, and due to that, when the huge burst time, high burst time process is executed fast. Due to that, the second process burst time which is low, but the arrival time is less. For that, he have to wait for very long time. I think that's the convoy.
Okay. Can you explain me what are the 4 conditions required to achieve synchronization?
Synchronization, primary two condition primary. It is uh, uh, progress and mutual exclusion, and the secondary is bounded weight and architectural neutrality or portability.
Okay. So can you explain me what are the four conditions for deadlock?
Deadlock for conditions are no preemption, mutual exclusion, hold and wait, and circular weight.
Okay. Let's say that the process. Let's say that deadlock has occurred, and you want to preempt some process in order to recover from the deadlock. So what are the criteria that you can use in order to select the process which
Deadlock.
is preempted in the out of the system?
Okay. So generally for the deadlock, 4 processes are there. I told that. In this process, the 3 processes are not executable in real life. Only one process, only one condition which can execute it in real life is circular weight. Or in circular weight, we can avoid deadlock if we assign the resource in a
No.
greater.
I'm not asking how you will avoid or prevent deadlock. I am saying that deadlock has occurred, and you have to preempt a process in order to recover from deadlock. So how will you select a process that out of like let's say that 10 processes, which process will be preempted?
Okay. The deadlock already occurred.
हाँ डेडलॉक हो चुका है.
Okay, and I need to select one process. Now, which
तो
is
आप
the
preempt करोगे. हाँ.
okay. So, I think the process which is less resources. Actually, I don't know actually the question.
Okay, no issue.
Don't understand.
Okay. So okay, my next can you explain me what is ostrich algorithm?
Ostrich is actually deadlock avoidance approach. It is generally used by the Windows or the Linux. When there is a deadlock occurs, they generally avoid the problem and restart the machine. Actually, in Ostrich, when the wind came and it stuck its head in the sand, that's the thing. I think Ostrich approach.
Okay, let me give you your feedback. तो देखो आंसर आपने सही करे हैं मोस्टली, बट थोड़ा कॉन्फिडेंस का इशू है कि यू हैव टू आंसर अथॉरिटी के साथ आंसर करना होता है. तो वो थोड़ा ऐसे लग रहा है कि थोड़ा डर के आंसर कर रहे हो.
Actually, this is my first mock
हाँ
test.
वो तो कोई दिक्कत नहीं, तो धीरे धीरे सीखोगे, बट हाँ दीज आर द
हाँ,
थिंग्स दैट यू हैव टू इम्प्रूव ऑन.
अच्छा, sorry.
दूसरा तुम्हारा
थोड़ा
जैसे एक
हाँ,
क्वेश्चन जैसे वो प्रोसेस वाला था, तो प्रोसेस सेलेक्ट करने के लिए यार बहुत सारे तरीके होते हैं. पहला है जिस प्रोसेस के बाद बहुत सारे रिसोर्सेज है वो हटा दो, तो रिसोर्स फ्री हो जाएंगे. या फिर वो प्रोसेस हटा दो जो बहुत ज्यादा रिसोर्सेज की डिमांड कर रहा है.
ओके
तीसरा वो है कि जिस प्रोसेस ने सबसे ज्यादा कंप्लीशन करा है उसको नहीं हटाओगे, जिन्होंने कम टाइम मतलब अपना एग्जीक्यूशन करा है उसको हटाओगे. चौथा, ऑस्ट्रिच एल्गोरिदम अवॉइडेंस के लिए नहीं होता यार, रिकवरी
इग्नोरेंस इग्नोरेंस सॉरी
रिकवरी में होता है वो,
ओके
अवॉइडेंस.
ओके
अवॉइड का ये होता, अवॉइड में वो चीजें आती हैं कि जब डेडलॉक जस्ट होने वाला है तब क्या करोगे,
ओके
है ना. तो ये आता है रिकवरी में कि हो गया ठीक है, फिर मान लो कि नहीं हुआ है यार, कि जैसे ऑस्ट्रिच होता है वो मान लेता है कि तूफान नहीं आया, तो बस मान लो कि नहीं हुआ, डेडलॉक खुद ही ठीक हो जाएगा. ठीक है, तो बाकी आंसर में थोड़ा अथॉरिटी के साथ आंसर करना है आपने.
ओके